Welcome back to part 3 of this video series. So far I've got a couple coats of the brown metallic hammered paint on here, and I've also applied some of the labels on here. You can kind of see those. The plan is to clear coat over this to kind of give them a durable finish and the lettering doesn't come off. I got some labels back here for the preamp tubes, for the power tubes, and for the tremolo and speaker jacks. So I had to run that through the printer a couple times to darken up the lettering. It's a little transparent, but I think it'll work. Alright, so I guess now what we're going to do is put a few coats of clear, and I'll show you that in a minute. Just want to show you guys some of the progress so far. So I got the whole chassis painted, I got everything mounted onto the chassis right now. Got our power cord installed, got our 6v6 GT power tube sockets, the octal sockets installed. I actually drilled the hole a little bit too big, so I had to make a couple of these washers, and this came from actually the amp itself. There's this plate here. It's like a phenolic material, it's non-conductive. I just cut out some little washers I could sandwich between that and the chassis to allow me to mount the sockets in there. It's got our speaker output jack, tremolo jack here. This is going to be our tremolo driver, 12AX7. Here's the preamp 12AX7, and here's another preamp 12AY7. And here's just some of the install so far. So I got all the 6.3 volt wires tightly twisted and soldered in. Got our main power supply coming in here. The hot wire goes to the switch first and goes to our fuse, to the center part of the fuse. So there's really minimal risk of anybody getting shocked. If the amp is off, there's almost no way that anybody can get shocked with this unless they actually come in here and touch their fingers to the hot lead to the power in. So that's probably the safest bet. Got our octal, our power tubes all wired up. Got our filter capacitors here. I don't know if you can see this very well. It'll focus. Looks like it's not focusing, of course. So I was able to get the full wave rectifier bridge mounted onto a single terminal strip. I don't know if you guys can see that down here. Maybe I can pull some of the stuff back and you can see that. That was a pain. I bought some diodes that were had thick leads on them, so it was hard to bend all this together. This took quite a while to get all this into one place, but I was able to make that work. Got some of the preamp section installed here. Again, I'm using all shielded wire for all the signal wires. So here's our 2 volumes, our tone, and this is our speed and depth for the tremolo. I haven't got to that point. I plan on mounting the tremolo section here. This is more the preamp section over here. But it seems like it's going okay so far. Looks pretty good. See if we can flip it over and get you a look at the front. So here's the actual front. You can see the fuse, on-off switches, the pilot light. Then I made the dials on a PowerPoint, and it spans the 300 degrees of the pots. So originally I was going to use that cream color, but it didn't really work out too well. It was too dim, so I had to go back and color it in with a felt tip marker. But all in all, I think it's looking pretty good so far. Let's see if we can flip this thing over. Let's show you the other side. So here's the Crate 30 power transformer, and then I had to buy a new output transformer for this. The output transformer had the wrong impedance input side for 6v6 power tubes. So came out pretty clean. I drilled an incorrect hole here, so I had to cap this off. I don't know why I did that. I thought this over for a long time, and I don't know why. I just drilled a hole in the chassis and screwed it all up. So other than that, I think it's coming out fairly good. You guys can see this so far. It's kind of dented up a little bit, but again, you're not going to see that portion of the chassis anyway, so I don't think it's that going to be that big of an issue. I call it Trem Joe Lux to kind of match part of my last name, and I think it's turning out pretty good so far. So I wanted to show you guys how I've been preparing all these shielded cables for this build here. So with shielded cables, you only want to ground one end, otherwise you can induce ground loops and actually induce interference into your signal if you do that. So here's obviously the grounded end of the shielded cable, but I cut the shield back and I put a piece of heat shrink over it, tin all the leads to keep them from fraying off and shorting out into anything that we don't want. And then on the other end, let the camera focus in there. So I just kind of cut back the shield and put a piece of heat shrink over it to prevent the wires in the shield from obviously contacting anything else. So you can see that only one side is grounded. That's how I've been preparing all the cables for this build. Alright, so here is the completed circuit that I came up with. So this main section here, kind of like we've stated, is the 5E3 Deluxe, and then this portion up here is the Tremolo circuit from the 5E9-A. So I tried a couple different things. So this is your first gain stage here up to 12AY7. Here's your second gain stage up the first triode of the 12AX7, and then this second triode on here of the 12AX7 is the phase inverter. So the 5E9-A uses the phase inverter to implement their tremolo effect. So I tried doing that, hooking in this up to here. It seemed to work, but if you look at the difference between a 5E9-A and the 5E3, they have both cathodes connected together of this 12AX7. So they just go into a gain, and then they have the phase inversion directly after that. They don't have a second gain stage like the 5E3 does. So generally, that's how they connected it, was to the phase inverter side. But when I did that, it essentially wouldn't work. So I connected it to here. It would work, but the depth pot was able to essentially shut off these tubes. So when you turn the resistance up all the way on this depth pot, it can affect the, I believe it's the cathode to grid voltage on the 12AX7, essentially shutting it off. So originally when I had this connected over to here, so this is just the first gain stage, and these different resistors are to try to equalize the signal path to each of the power tubes, because you actually get amplification here, and you do not get amplification off of the cathode. So they have these different resistor networks here to try to reduce the gain of the amplified stage of this 12AX7. So originally I had this connected to the cathode here, and it worked, but when I turned the resistance up all the way, it would essentially shut off this gain stage here and pretty much shut off the entire amp. So I added a switchable 250K linear depth pot that had a push-pull on it, and I can show you that in a second here when we do the demo. But one part of the switch is connected to, so this is the tremolo effect. It's going to be altering the basically the bias of this first 12AX7 here. It seems to work pretty good. And then also there's an oscillation switch here on the 5E9-A that's utilizing the second portion of the switch. So I probably didn't have to do that, but I figure if you're going to shut off, by having this switch open and then this open as well, it pretty much shuts off the entire tremolo circuit. And I did notice too that when I left this connected, it would affect the gain on this first 12AX7, even with the resistance completely turned all the way counterclockwise. So it's by doing this method, the switchable, these two switches here, it pretty much eliminates the tremolo circuit from the entire rest of the amp. So when it's off, it's just going to be just a straight 5E3 Deluxe circuit, and then when you use the switch, then that's when you incorporate the tremolo. You can play with that when you're playing the amp. So another thing, we had to use the bridge rectifier like we talked about. I couldn't use the rectifier tube, otherwise the voltages would be too low. Added a standby switch here. Like we said, we grounded the center tap of the 6.3 volt windings. I switched up this portion here. I added a 470 ohm 2 watt resistor to the screen resistors for the power tubes, and I adjusted this dropping resistor to 4700 ohms to try to match the original 5v3. I think it's, when you factor in these screen resistors, I think it's an extra 70 ohms or something like that. I think this is originally 5000 ohm resistor, so it's not that big of a change there. But other than that, that's how I made this work, and it seems to work pretty well. So yeah, I just wanted to basically go over that schematic. I'll post this in the comments so you guys can reference this in the future, and then also the parts list from Antique Electronics Supply. So if you guys wanted to do this same type of build, you'd have all the parts to be able to do this. Okay, so first things first, you can see here, this is the filter capacitor section here. So you have your rectified voltage coming in here. This is the first smoothing capacitor, second and the third. You can see that this last capacitor here is not connected to this ground. I have isolated this completely from chassis ground, and especially from the center tap winding. And I'll show you that in a minute, what happens when you connect the center tap filament winding to this node here. But I was getting a pretty pronounced hum in the original design. I had all of these connected together, and all of these ran to a star ground to the safety ground, which is the green lead coming from the power cable, and then also the center tap winding for the filament was connected there as well. So I found that when you connect the center tap winding to this node here, that induces hum into your preamp circuit. So by this point, when you get to this capacitor, it's pretty much straight DC power. So you're not going to have any of that oscillating AC sine wave at this section here. So you can isolate this completely from the chassis ground. I actually don't even have this grounded right now to the safety ground. I might do that a little bit later, but I actually did test it. I connected a lead from here to the green lead of my power cable. I didn't notice any change to it, so I don't think it's that big of an issue. And then actually the original 5v3 circuit design was designed that way, to have all of this isolated from chassis ground. So yep, that was one thing I noticed with that, and it took a long time to figure that out. I had to desolder a few things and change some wiring around to make that work. Let's see if I can show you guys a couple other things briefly here. Zoom out. So here's my preamp ground bus installed. So originally I had everything connected to these terminals here, which are also connected to chassis. So like I said, I isolated everything from the chassis ground through this bus connection here. I'm calling this like the preamp bus. So I went ahead and did that, and once I did that, that pretty much eliminated all the hum in this amplifier. And also I experienced some issues with the transformer that was making an audible hum, so I tried a few different things with that. Let's go ahead and move this over here to the transformer section. Zoom out again. Sorry about this. So there's an audible hum coming from the transformer, and I tried a few different things. I tried like these nylon bushings to try to isolate. Like I figured there was some kind of conductivity between the transformer laminations and getting in contact with the chassis, inducing some kind of like EMI into the chassis. I tried isolating it with these nylon bushings and with these stainless steel screws and bolts and things. None of that seemed to work, so I went back to the original hardware setup. And I think this is just regular steel hardware, but for whatever reason, I went back to the steel hardware, and that seemed to also help with reducing the hum. I don't know if it has something to do with messing with the magnetism when you use stainless steel, because you can't magnetize stainless steel. You can magnetize obviously steel, but stainless steel you cannot magnetize. So maybe it has something to do with that. I'm not entirely sure. Yeah, other than that, those are some of the things that I experienced with this. Can't really think of much else at the moment. I got kind of happy with the solder gun on a few of these, and I had to fix some of the wiring. I have like this paint on liquid tape, they call it. It's just basically like paint on electrical tape. Works pretty well. And one other big change that I had to make from the original circuit is, normally this is a 250 ohm 5-watt resistor. To keep the plate dissipation in check for these power tubes, I had to switch this to a 300 ohm. So as it is right now, my plate dissipation for this tube, for the left tube, is 9.9 watts, and this right tube is 10.1 watts. So if you follow the 70% rule for fixed cathode bias, that's within spec. That's very close. So I think the amp sounds pretty good. One thing too about the Tremolo circuit here is I had to add this additional 0.1 microfarad capacitor to help slow down the tremolo a little bit, and then I also had to use this switch here to so I can isolate the depth and the speed control from the main circuit. So when I had this initial, I'll show you you guys the schematic here in a second. I had the depth control hooked up to the cathode of the Tremolo oscillating tube. Or sorry, no, it was connected to the cathode of the first preamp tube. It would, like, if you turned it all the way up, this pot all the way up to max resistance, it would completely shut off the signal. So it would drain the signal to ground. I couldn't really figure out exactly why I was doing that, but I used this switch. This is a 250k ohm pot with a double pole, double throw switch on it. So when you pop this out, pop it in, it makes contact with these, or keeps the circuit open here. So this is actually the depth and the speed control here. So right now when it's pushed in, it's completely off and it's isolated from the circuit, so that the tremolo section here is completely isolated. It's not doing anything at all. When you pop this open, that initiates the tremolo. So I think that's kind of a cool feature. Kind of keeps it sleek. You don't really notice it. All you're going to notice is like this this knob is different from the other ones. You'll kind of wonder why, and you go, oh yeah, because it's got this push-pull switch on it. So, but yep, I think that's pretty much it. You got all the wires tightly twisted for all the AC, you know, for the filaments and for the high voltage wiring. Yeah, so I think now all we really have to do is do a quick demo. I'm going to do a more in-depth demo, so hopefully you guys get a better idea of what this thing sounds like. I think it sounds really, really good, and it was totally worth the time and effort to do this. I mean, I had this amp, it basically was completely useless. I could have just thrown this thing out. It didn't work at all. Kind of like in the previous videos, I was showing you guys there were some issues with one of the power tubes. I looked at a video from Brad, the guitologist, and he worked on some crate amps before, and he had a similar problem with one of those. It's just, you get these PCB board systems, they get one little component wrong with them, and they're really hard to trace down. So it's kind of hard to say what the issue was with that amp, but I think this is totally worth the time and effort, and I would really encourage you guys to go ahead and do something like this if you have the abilities and the tools to do it. But it's been really fun. I can provide you with the parts list and the cost. I want to say it was around $360 or so to do all this. That includes everything, all the tubes, all the components, everything. I was able to reuse the original power transformer, and that really helps reduce the cost down. I did have to purchase a different output transformer to match the 6v6 GTs, because the output transformer in the Crate 30 is not designed for these tubes. So other than that, I think it was worth it. It was a lot of fun, and hopefully you guys agree that it sounds good. So let's go ahead and do the audio demo. Here's the final demo setup we have here. Here's my Gibson Les Paul Special with P90s running through the Shure SM57 microphone here in the same position as we marked before we started the build. See there with the little L-shaped painter's tape. Running through a Behringer UMC 22 interface, and we're just going through the the bright channel on the number one bright channel. That seems to have the highest gain. The normal channel is not really usable. It's pretty muddy and dark. It doesn't have a lot of gain to it. So I think for modern guitar type playing, the bright channel, the first channel is typically the best. I think it sounds the best anyway. So I'm just going to run it through that. Looks like so the bright volume is about 4 right now. Our tone is about 9. And the other two knobs there are speed and depth for the tremolo, which we'll demo here in a little bit too. So let me just go through a few sounds and record that for you guys. Alright, so now we're going to go ahead and try the tremolo. So we're on about a speed of 6.5 and depth is about 8. That's how you turn it on. Just do that push-pull pot.
Bye.